Okay, thank you very much for coming in these big numbers to my talk on a, well, let's say, some might say rather basic theme. Microservices love domain-driven design, and I will elaborate in this talk why I think that the both are a very good fit together, and why I think that teams that adopt a, let's say, microservices development and architecture model will benefit greatly from the ideas that Eric Evans sketched out in his absolutely amazing book called Domain Driven Design. So a disclaimer up front, many of these ideas come from this book from Eric, and I just summed them up and put them a little bit into context in terms of how they might help us with the idea of domain-driven design. Just a short introduction to myself. My name is Michael Plöd. I work at InnoQ as a principal consultant, and basically I've been doing software development and software architecture consulting throughout the last couple of years, and some of my experience also is in this talk. You can follow me on Twitter @bitboss. So let's take a look at domain-driven design and domain-driven design in microservices. If we look at a lot of, let's say, conference presentations, a lot of blog posts, a lot of some of the books, you obviously encounter the concept of the bounded context as a fundamental tool for defining the granularity of a microservice. But I think domain-driven design and microservices are not just only about bounded context. Of course, and we will cover that in the talk today, the bounded context is a fundamental principle for domain-driven design in a microservice world, but it's not everything. And if you take a look at a lot of, I would say, domain-driven design stuff that's around, you can get the impression that domain-driven design is mainly about repositories, entities, services, and aggregate. And that's also not true. I think there is more to both views on them. If we take a look at this topic in the context of microservice, I think domain-driven design helps us in 4 major areas in order to create, design, and build good microservice landscapes. First of all, we have the chapter or the topic strategic design. In strategic design, there is the bounded context, obviously, there's the context map, and some patterns how certain bounded contexts and modules can act together. In addition to that, there's also the chapter of the building blocks. That's where all the entities, repositories, and all this stuff is residing in. Last but not least, we also have a lot of content on building large-scale structures in the area of domain-driven design. So there is, for instance, a pattern called evolving order, responsibility layers, and stuff like that. And finally, if we come from a, let's say, very monolithic world, when we work at a company that has a grown IT landscape, and a lot of companies have a lot of really badly grown IT landscapes. How do we get to microservices? There's also a very interesting part in the book, Domain-Driven Design, called distillation. So how can we actually distill a core domain from a grown system? And we will elaborate on all of these 4 aspects of domain-driven design in the context of microservices today. Let's start off with, obviously, the obvious chapter, strategic design. Strategic design in domain-driven design is mainly about the bounded context, but not exclusively about the bounded context. It's also about the context map and some patterns like shared kernel, customer supplier, anti-corruption layer, and so on. And let's take a look at the bounded context first. If these gray dots there represent some business domains, we can say that every sophisticated business domain. For instance, and that's an example I will carry out throughout my talk today, a system for organizing conferences, like this great microXchg event here. We will identify that there are certain areas to the system that have certain specifics. For instance, a registration, where we register for the conference. For instance, a call for paper system, where I handed in my talk to this conference. Then there is a conference management system that pulls together the schedule for the conference. There is a system or a microservice for printing these badges and stuff like that. And these can be seen as bounded contexts. And a bounded context is basically a set of modules and maybe also other bounded contexts that in a combination build up the system and the business functionality, the business domain completely. And that is very important as well, it's also a boundary for the meaning of a given model in this context. Let's take a look at a simple example. So we have a system that manages all the IT of the microXchg event. We have and that is obviously not a complete example. I just picked out 3 bounded contexts for simplicity's sake. We have a reservations bounded context, we have an event management bounded context, and we have a bounded context for the badges that everybody's wearing. So we have our customer here. And if I take a look at this customer, there are several views on this customer depending on the bounded context. For instance, in the reservation system, I'm interested in the customer's name, some payment details, for instance, PayPal or credit card details, the address, and the company that the customer is working in. The event management bounded context sees the customer in terms of session registrations. If we have a conference where you can register for certain sessions, something like a pre-registration that they know how big the venue should be for given talks, and also lunch preferences that they know how many vegetarians or even vegans are at this conference in order to scale the food for the conference. And then we have the badges system, and all we care about the customer is what we see here, like the name, the company, maybe a Twitter handle, and I think that's for the contact information of the specific person as far as I know. So, yeah, feedback machine, yeah, exactly. So that's the view on the customer in terms of the bounded context badges. So there's a total different view. And let's digest a little bit deeper in there. What we can say is that each of these bounded contexts has its own model, its own view on the customer. And this is basically a major enabler for microservices because we can encapsulate the model customer to a microservice. I mean, most of you have already heard the slogan or the pro tip, model your microservices according to bounded context. I think that for most of you, this shouldn't be anything new. But this is a major driver, obviously. And if we take a look at the name of the customer resides in the badges bounded context and in the registration. So we could think, maybe we have some shared data. Would we want to move that shared data to a dedicated bounded context? I mean, this is a simple system. There is no big necessity for doing this, but there may be systems where this might be a necessity. All of this gets really interesting if we map these contexts together. I mean, systems, especially highly distributed systems, are usually not consisting of isolated islands that live on their own and don't communicate with another. And there comes another idea from domain-driven design into play. And I think this is a very interesting approach, especially for organizations that come with an existing landscape and they want to move to a microservice world. And that is the context map. The context map goes ahead and puts all of these bounded contexts in a relation to each other. So far, we just took a look at these contexts from an isolated view. We just saw, okay, there's the badge service, there's the registration service, and so on. But how do they communicate with another? So the bounded context itself doesn't give us an overview of the system. It's just, okay, there's these islands, there's these services, and the concept map describes the contact between these modules and contexts. And it is a really great starting point when you want to start a transformation of the system, because it gives you an overview. How do these contexts, how do these microservices or these legacy systems relate to each other? And in which way do they relate to each other? And the way they relate to each other is defined by a bunch of, I think it's 7 patterns. And let's elaborate them a little further. The first of these relationship patterns between contexts is the shared kernel. The shared kernel means that 2 teams and 2 bounded contexts and maybe 2 microservices share a subset of the domain, including code. Maybe they share on the level of the database, their data. And this shared kernel is also often, especially in the literature, referred to as a core domain. In terms of independence of teams, this might get a little bit difficult, but we will elaborate the topic of team independence, of team dependence, after these patterns a little bit deeper. Another pattern is the customer-supplier pattern. In this case, and that is something that I see very regularly in, I would say, typical IT landscapes at bigger companies, is that there is a system that is providing some kind of functionality, some kind of service, and then there is a customer that says, okay, dear delivering system, I need these new features, I need these new data attributes, and please deliver them. And the customer sometimes also has a veto right on the supplier's team. When they say, okay, we want to change our interface, they can say, no, you can't, because we depend on you, and this doesn't work. And that is usually the pattern that we see in IT landscapes that struggle with continuous delivery problems, where these systems can't be rolled out or deployed independently of each other, because when I change something in one system, it pops up in many other systems. A little bit similar to that is the integration pattern of the conformist, according to the Domain-Driven Design book here. In this case, it's not really I would say, a customer-supplier thing. It's more a matter that the requesting service, the requesting team, just adopts the model of the upstream system. So they just say, okay, whatever you got, we integrate with that, and we just stick to your rules. So they don't have any, let's say, veto rights on that. So when this team over there on the right side messes up, it obviously also messes up the model of the downstream team. So it propagates throughout the system. The next option that can be adopted or can be seen is the so-called anti-corruption layer. This is a layer that isolates the client's model from another system's model by a translation model. So before we take up, let's say, this over there is the badge system, and we have the registration system where we draw out the user registrations for the conference in order to print the badges. So we have an option that we just share the model, which we don't want to do. We just want to grab some of the model and translate it to our own model as the badge bounded context. So there is a piece of code that translates model A to model B. And this is a very interesting option, especially when you migrate to, let's say, a microservice environment or a self-contained system architecture, because this anti-corruption layer works as a, let's say, protecting shield against the outside of the system, because we still, in our world, in our own world, stick to our model that fits our needs. So in case of the badges system, we don't import, for instance, the credit card details of the customer. We don't care about that. We just take the name, the Twitter handle, the job description, maybe the company, and that's it, and we do our thing with it. And we have a tiny piece of code that translates model A to model B. And if the registration system over there suddenly messes up their model, or if there's some model changes, we don't usually propagate these changes to our core domain. We just have to change the code and the translation services in the anti-corruption layers code. So that is obviously a very interesting and a very good pattern where we can integrate other systems that exist, but still move on with a more dynamical pace in our own bounded context. Separate ways is, well, as the name says, separate ways. There is basically no connection on the model side. Both teams do what they do. Usually we combine these with, let's say, an event-based system where we just consume some events, put out the data that we want, and work with our own model. And basically, both teams don't care about the rest of the world. So they do their thing. They don't integrate or they don't synchronize with others. They don't translate stuff. They just consume some events, some models, and work on their own sets of data, totally independent. Of course, obviously, this is a very good way to, let's say, achieve a high dynamic in terms of deployment speeds, deployment independently, etc. But I would say, especially if you come from an existing system, this may be hard to adopt, because you will have to relate to, let's say, some other model in some place. The open host service is a pattern that says each bounded context offers a defined set of services that others can consume. So we are the registration system, and we may offer a service, get customer details. But this service is, let's say, an add-on to the core domain of this bounded context. So it doesn't necessarily inflict with the core domain of this bounded context. It's just an open interface for others to get data from us, for instance, through a feed system or through some REST API or something like this. This is also a pattern that comes in very handy when we want to integrate with other systems, because we could go ahead and write a dedicated service for, let's say, if we want to transform our IT landscape, we write some dedicated service for the old world, and the new world integrates with the old world on these kinds of services. So they don't adopt the old world's model. They don't integrate on a database level. They just go through these services. The last but not least, the last one is publish language. It's quite similar to open host service, but it's, I would say, on a more abstract level. The publish language goes ahead and does the abstraction of the domain model in the form of a common language between these bounded contexts. I think especially in a, let's say, microservices world, in a distributed systems world, this pattern may become a little bit dangerous, because let's imagine we want to create a ubiquitous language over all bounded contexts that are, let's say, fundamental and a requirement for all other bounded contexts that they have to adopt it. The danger is that we basically end up in something like a canonical data model, and this is, I would say, a lesson learned that this is not the best, if not a bad idea to adopt. So if we go for the published language, it is, especially in very conservative environments, classic environments, very tempting to go, okay, we define our company's ubiquitous language through this. So this is not very practical in a microservices world. But it has to be said because it's part of the book, and in the context, in other contexts, this pattern may make sense. So how do we work with these patterns when we start mapping out a, let's say, a context map? Let's say we have 4 systems, A, B, C, D. A, for instance, is our registration system, B is the conference management system, C prints badges, and D is a call for paper system. The arrows on the up of the slides, these arrows, they are messages that are being sent between the systems. So for instance, A and B have a bidirectional relationship. A calls B, B calls A, both consume messages from either bounded context. B calls D, D calls C, and A calls C. What I suggest, and this is also a notation that Eric Evans has used on some other conference talks that I've seen by him, and I like this notation quite a bit, is that we map out these bounded contexts, these context maps, in terms of the patterns that I just called. And don't get irritated by some of the errors. For instance, there is an error from C to D, whereas the messages or the call direction is from D to C. What does this mean? This means C conforms in terms of the conformist pattern with the data model of D. B has an anti-corruption layer for the model of D. So B is translating the model of D to its own world. A and B, they partner together, so they have a shared kernel, a shared model between the two. And C conforms to the model of A. What is now the interesting information that we can draw from this image? The interesting information is that, for instance, if we have substantial issues because of a business change and whatever, in the model of D, it will directly influence the model in C, because C conforms to the model of D. So we see a cascading of these, well, let's say business models in these bounded contexts. The same applies, let's imagine, A messes up. The team of A creates a crappy model. They introduce a lot of bugs, a lot of problems, and they don't get behind an evolving system. This means that this change would escalate towards C, because C conforms with A, and to B. However, changes to D's model, would only be a problem for C, but not for the system in B, because B has an anti-corruption layer. They just have to adopt their translation service. And this is especially interesting when you map out existing landscapes, existing systems, and when you want to transform them, because this gives you a good idea where to start. Do we have any hot points? Do we have, if we apply something like I mean, that sounds a lot like consulting slang, but if we apply something like a heat map over this thing, we might see that C is a little bit problematic. Or, no, A is a little bit problematic. We should take a look at everybody who's integrating with A, because if A messes up, it will escalate to C and it will escalate to B. So we can identify spots where to start off, for instance, with a, well, let's say, initiative for extracting some functionality to new domains. Apart from this thing, there's also a kind of a relationship to the idea of Conways Law, because these patterns, they have an influence on the team communication. For instance, we have a very high degree of team communication on the shared kernel. These teams really have to sit together very tightly. They have to communicate intensively in order to get their models right, in order not to have any side effects or something like that. Whereas, for instance, customer and supplier and conformist, yeah, they still have a tight coupling, a tight integration, but not as hard as the shared kernel, for instance. And the anti-corruption layer and separate ways and open host service, they are patterns that, well, tend to support team independence, especially separate ways, of course, open host service as well, and the anti-corruption layer, yeah, there's some team that has to do something in order to adopt model changes, but fair enough, it's isolated. So there is a direct relationship. Now, we have covered strategic design. Let's take a look at the next part, which are the building blocks. The building blocks help us to structure our microservices and our bounded contexts in their own boundaries. So, as you can see on this graphic over there, all these patterns, aggregate, entity, value object, factory, repository, and service, they are inside a bounded context. And that is also the scope of these building blocks. So these are usually not building blocks that you span across bounded contexts. This is inside the internals of a bounded context. I am especially let's say, a fan of the aggregate pattern in combination with entities and value objects. And I will cover them in a little more detail, whereas I will only shortly touch on factories, repositories, and services, because these are, well, rather obvious patterns. But let's first start off with entities. Entities represent the core business objects inside a bounded context. So they are really the living and breathing core inside this context. An entity also has always a constant identity. For instance, if you take a look at a bank account, it has an account number. That a bank is changing their account numbers is, I would say, a rare occasion, because it costs them money and it makes their customers very angry. So obviously, this is a very constant identity, and this is also an identity that outlives many IT systems running on the domain bank account. And an entity has, by default, its own life cycle. So an entity can be created, removed, and so on, usually independently. We will add a little more context to that in a couple of minutes. On the other hand, the value objects don't have an identity in this case. The identity of a value object is always derived from their values. Let's take a look at the color, for instance. If I have this color, this dark blue color on my slide, all I usually care about is about the red, green, and blue value. I don't care, is this like color instance number 132 or something? I just care about the values, or the monetary amount, for instance. The monetary amount is like some sum, like a decimal number, and a currency. That's all I care about. 100 euros, 100 pounds, $100. I don't care which $100, which $100 bill exactly, with the serial number of the $100 bill, for instance. And these value objects don't have their own life cycle. They always live on the life cycle of an entity that is referencing them. In addition to that, I think that value objects are a really interesting pattern for modeling inside of your business domain, because you enforce a very clear life cycle of the domain graph with this pattern. And if you took a close look at both the slides to entities and value objects, you will find out that I had one circle with the same name on both. I had the customer as an example for an entity, and I had the customer as an example for the value object. Now, what is the customer? Is it an entity or is it a value object? Why did he mention it on both sides? The meaning is highly dependent on the bounded context that this, let's say, domain object is living in. For instance, a customer is, of course, an entity in a CRM-like application. Each CRM system, each CRM-bounded context is basically customer-based. It's the central aspect in this context. Whereas for the badge printing service, we don't care about the customer. We just need the name, the Twitter handle, and that's it. The same applies, for instance, to the address in many systems. For instance, a logistics system is highly interested in the address as an entity, whereas some simple online shop that is sending out handmade teddy bears to some people just needs, well, the name, the street, house number, postcode, city, and that's it. It's just the combination of the values. So always keep in mind, if some object is an entity or a value object, always depends on the bounded context. The next pattern is, in my eyes, the most interesting pattern in this building blocks chapter of domain-driven design. It's the aggregate. And do not underestimate the power of the aggregate. The aggregate is a pattern that groups mainly entities. I mean, the grouping of entities and value objects is totally straightforward because there is a clear life cycle, there is a clear set of dependencies. It gets interesting when we combine some entities. Let's take a look at this example here. It's a, let's say, a mortgage loan system. And we have a bounded context loan application form where we apply for a mortgage loan. I want to buy a new house in Munich, which is very expensive, so I need a huge mortgage loan. This mortgage application has a self-disclosure that says, okay, Michael Plöd is earning this and that. He has some other loans. He has to pay for some children, and so on. We have a couple of loans. For instance, in Germany, we have KfW support for loans, and we have some redemption details, how we want to pay the loans back. And what we do is we group these entities together to an aggregate and define one entity as the root entity of the aggregate. In this case, it is the loan application form. On the other hand, we have a different context, the customer with an address. And the customer in this case is the root entity of the customer aggregate. And you are only allowed to reference into another aggregate to the root entity. So I wouldn't be allowed to reference from customer to loan. If I want to get to the loan, I need to go through the loan application form. And this root entity is also in control of the life cycle of the whole aggregate. So if I, for instance, delete the loan application form, I also remove the loan, the self-disclosure, and so on. Now, how does this relate to microservices? First of all, it helps us to structure the system inside our bounded contexts. And it is also a good advice for the granularity of microservices. We can go ahead and that's something I read quite often, and something that I also agree to is a microservice should have either the granularity of a bounded context in terms of max size, or the granularity of an aggregate in terms of min size. Don't structure microservices around entities. So the aggregate can be a minimum granularity for a microservice, for instance. In terms of factories, services, and repositories, I will go through this very quickly. Of course, yes, factories take care of the creation of entities, aggregate graph instantiations. Repositories encapsulate and represent data access, so it's an abstraction for the data access. And services implement the business logic that relates to multiple entities and aggregates. So we combine entities and aggregates together. Now, after having taken a look at the internal building blocks, let's go to a larger scale. The large-scale structure in domain-driven design has, I would say, 3 major patterns. And 2 of them are especially interesting for our case. And we will take a look at the 2 of them. The one is evolving order. The other one is responsibility layers. And then there's also another pattern called system metaphor, which I will not cover in this talk because I don't see the high impact in terms of the microservices with this pattern, and it would also not fit into the time frame for the talk. Let's start with the evolving order. What we sometimes see in organizations, that we have some chief ivory tower architect or chief ivory tower architecture team, and they come up with a lot of regulations, rigid development guidelines, inflexible architectures, clear rules and conventions for everything. I don't need, and also this quote, I don't need expensive developers, I prefer cheap ones, and I do the thinking for them. Michael Nygaard had a very good quote on Twitter recently that said, cheap developers are cheap by the hour, but ungodly expensive by the year. I thought that was a really good quote. And that is exactly the mentality that we see here. What we see with systems that are being developed in this way is that you have a development team or a bunch of developers. And the usual quotes are, the system is too complex, let's dumb down the system to fit some of these rules, and we need a workaround for that, we need a workaround for this, we need some reflection magic in order to dodge some of these rules. And, well, usually how do these projects end up with unmaintainable code? And the idea of evolving order, if we take a look at the arguments, that's some quotes out of Eric's book here, a little bit simplified, is let large structures evolve, don't over-constrain design principles. These large structures should be applicable across bounded contexts, and, however, there should be some practical constraints. Now, if you take a look at what many, let's say, experts on microservices, on distributed systems tell, if you take a look at a lot of the case studies that are out there in the market, this should sound pretty familiar with you in terms of microservices. So you should make your bounded contexts, your microservices, your aggregates, in a way that they can evolve, that you can change. This is basically one of the core idea of the microservice idea here, which is a fundamental part of domain-driven design. Another interesting thing is the responsibility layers. In the domain-driven design book, the responsibility layers have mostly been written down for, let's say, internal structures of bounded contexts. If you read the book, yeah, sometimes you can see the idea that they span several bounded contexts, but you can actually go ahead and adopt the idea to a broader scope. For instance, we have 5 microservices here: event management, speakers, mailings that send out some emails, some letters with ads and what stuff people usually don't want, and the badge printing system. And each of these microservices is structured according to a bounded context. But inside these contexts, the developers obviously have the chance to use these building blocks. And the responsibility layer is not about structure your microservice with a service, some entities, and some repository. It goes a little further. What it actually says is that you should structure these bounded contexts according to responsibilities. For instance, you can have, I would say, some upstream customer-facing bounded contexts with web UIs, with, I would say, user experience. And it's also very important to model these bounded contexts according to business capabilities. That's very central. Don't model them for data, model them according to business capabilities. And on the other hand, you could also have some business capabilities that are rather downstream, that send out some emails, that integrate with Twitter, that go to an back-end SAP system, and so on. So you could actually structure these contexts according to several layers of responsibility. And if you combine that with the idea of the evolving order, you can set certain, lightweight rules for each kind of responsibility. For instance, a batch bounded context, a batch-centric bounded context, obviously has different architectural requirements than a web-centric bounded context. And finally, after these ideas of the large-scale structure, we can also find some great ideas in domain-driven design regarding moving from a legacy-centric system to a more microservice, self-contained systems-oriented kind of system. And that is in the chapter distillation. The distillation helps us extracting microservices out of existing monolithic applications. What does Eric and the domain-driven design community say about this kind of thing? Well, go ahead and identify in your large, big piece that you have a core domain. What is really the core business domain of a system? For instance, a credit application system, where we apply for a credit online, and it gets processed down the line in that system. Well, we could identify, for instance, the credit application as the central core. As the system, and we can extract this core. And starting from that, we should make very clear what is the vision statement for this new context that we have there. Yes, it sounds like quite a bit of, I would say, paperwork and stuff to do right there to write down a vision statement, but it's very important in these first steps of distilling out a core, a first self-contained system or first microservice out of such a monolith, that we define what are the business capabilities of this thing. This is not about technology, about some infrastructure components. This is certainly focused around the business capabilities. Where is the boundary of the business capability? What does this core do? And what is also very important, what does this core not do? And then we create a distillation document that describes how we extracted the core from this application, where the boundaries are, and how they get implemented. You can do that in a wiki or something like that. It doesn't have to be some dusty template or something like that, but it should be written down, because it's very important going further from that, because this is going to be an iterative work here. We will do some identification of a new subdomain, we will extract this one from the core, we will clean up the separation, we do some internal refactorings, and we start off again with the next one. And without a clear vision and without a clear knowledge and view of the business capabilities and the boundaries of the business capabilities, we run the risk to, let's say, not get the bounded contexts right in this place. So finally, if we take a look at the topics of strategic design, the large-scale structure, the internal building blocks, and the distillation, we can easily see that, I would say, microservices really love domain-driven design. Those two concepts fit very, very well together, and don't just, drive it down only to the bounded context thing, but think it in a little larger scope in this case. So I'm done with my slides and with the talk. I think we have 5 minutes time for some discussion, for some questions, and yeah. No questions? Okay. Yes, there is a question.
I would ask, how would you go about drawing this context map? Mm-hmm. So what would be your first steps? Would you talk to business people about
okay.
So what's the process to
okay.
to see what are my bounded contexts and how do I
okay.
draw this map?
Mm-hmm. So, well, first of all, it depends. The question was, how do I start with drawing this context map? Do I first start talking to business people? Do I take a look at the systems? My suggestion would be, it depends where your starting point is. If you start off with an existing landscape and you have a very good view of the landscape, I would first of all go ahead and take the systems that you want to take a look at and see how they relate to each other. Because obviously this is about, in a first step, between systems that we want to transform. So do we have, for instance, in one system, an anti-corruption layer for another system? Do we have a shared model? Are two systems accessing the same tables on a database, for instance, which is something that happens quite often, for instance. So you could start off with that, and then what I also suggest, and you had a very good point with the business people, I would talk to the business people, hey, what is actually your view on your business domain here? And then you can, I would say, create let's say, a business domain map with the main business domains, the subdomains, and you could combine them together and see how these systems with their relationships actually map the real view of the world. And where do we have differences? Where do we have a good fit? For instance, quite a popular topic is that we have a domain, let's say a business domain customer, but there is suddenly 5 systems doing exactly the same thing, or maybe sharing data and or replicating data between them, and then you can find, okay, there I might have a problem. Maybe I want to unify some of these things. All right. So if there's no further question, I say thank you very much for attending the talk, for the shown interest. I'll be a little bit... Okay, I'll be around at the conference for some time, and you can chat me up at the InnoQ booth or something like that. Thank you.